Welcome to a lesson with Dr. Powell. Let's take a look at how we can think about the idea of a forest and trees and incidence matrices. And in particular, how we can think about connected components. So a tree is connected. It has one connected component. So after you, looking at the incidence matrix to take it down to Smith normal form, we should end up having one row of zeros at the bottom for one connected component. Now for forest, we can have more than one connected component, but a forest is made up of trees. What is a tree? A tree is something that has no cycles, even if we change direction. For instance, this right here may not exactly be considered a cycle if you're thinking about direction. However, you can modify direction and change this to go the opposite way, and it would be a cycle going around. With that in mind, we're going to think about a tree as being something that has nothing that you can even turn around to become a cycle. Or if we just drew something like this, no shape like this, which is closed. So a tree has nothing like that, but it simply has branches coming off and not going back to where to loop around. Okay, so that's what a tree is, and a forest involves multiple trees. So based off this information, let's think about what we can do. Now, when we do column operations to get down to Smith normal form, what happens is we eliminate cycles. And if all cycles are eliminated, we have all the columns that will be non-zero that we will have in the Smith normal form. So we actually know exactly what the range is of this matrix just by looking at what's going on here. We know that the range, or particularly the non-zero rows, we know how many non-zero rows we'll actually have in the end it'll be precisely the number of edges. Notice that the number of edges in a tree is one less than the number of vertices. That's always true. Now, what if we had a forest, and suppose that we had, suppose in that forest, we have 8 edges, and then the question is, what if we had, so we have eight particular edges, and let's suppose that we have 15 vertices. Then how many trees are living in that forest? Well, okay, forest means it has no cycles, which means 8, well, actually, the number of edges you don't have to eliminate in the columns to Smith normal form. So the 8 edges actually is the range. So the number of connected components is actually going to be 15 minus 8. So this particular forest will have 7 trees. Notice that if there were 14 edges, there'd be 15 minus 14 would be 1 tree. So a tree has one, again, repeat, a tree has the number of edges is always 1 less than the number of vertices. I hope this little discussion helped you think a little bit more about what a forest is and trees are, and how to think about the incidence matrix and the Smith normal form. Thanks for watching.